Hello 3-4. Just having a quick look at interpreting data or reading pictograms. So this one is about, well, let's have a see. Is there a key? There's no information that tells us exactly what this is, so we'll have to interpret it using the questions. How many children like blue? And we can see all of the coloured patterns here to show us how many children like blue. But remember, it's always important that we check the key first. So each circle here represents 2 children. 2 children, 4 children, 6 children, and half of 2 children, which is 1 child. 2, 4, 6, 7 children. How many children like blue? 7. How many children like red, blue, and pink? See if you can work out how many like red. Did you get 8? How many votes did the most popular? So the most popular is the one that is liked the most. The most popular is the one that comes to the highest point because it's got more choices. In this case, it's yellow. How many are there in yellow? 2, 4, 6, 8, and half of 2, which is 1, makes 9. This one's interesting. How many children voted all together? Well, to find out all together, we have to add them all. So to do that, we need to find out all of the numbers first. So we've got 8. I'm going to write it above the column. 2, 4, 6, 7. 2, 4, 5. We know this one's 9. And 2 times 3 is 6. So we can add all these together now, and that will give us the all together, the total of all the votes. 8 adds 7. I'm going to do a little bit of partitioning here. 7 is made up of 2 and 5. 8 add 2 is 10. Add the rest, which is 5, is 15. Add 5 is 20. Add 9 is 29. 29 add 6. Again, I'm going to partition the 6 into 5 and 1. 29, 30, add 5 is 35 altogether. If you find it easier, you can go and get this number of things, pieces of Lego perhaps, and count them all up. What is the difference? Remember, we talk about the difference quite a lot. Difference is subtracting. What is the difference in the number of votes for green and red? Green is less than red by how many? By 3. Okay, so today we're going to be doing some reasoning and problem solving. So have a look at this. True or false? The pictogram below shows the results of the tally chart. We're going to have a look. We already know that it's false because it's giving us a clue down here. And that's how we're going to answer the question, by starting off saying whether it's true or false and then explaining it. The key tells me that each circle represents 2 drinks. The number of drinks sold here, I'm going to write the number in, is 10. This one is 14. Here we've got 20. And lemonade is 10. Can you see how I did that? 5, 10, 15, 20. So over here, if each one is represented by 2 drinks, then we should see 10 divided by 2. Well, I know that 10 divided by 2 is not 4. 10 divided by 2 is 5. If there are 2 drinks for every water, there should be how many? That's right, 7. Milk should have 10 and lemonade should have 5. I wonder what it is that they've done wrong. In order to answer, I'm going to try to correct it. So this one should have 5. This one should have 7. This one should have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this one should have 5. 1, 2, 3, 4, 5. I'll cross through those. So the answer is false because juice should have one more. Water should have 4 more. Milk should have 4 more. And lemonade should only have 5. Quite a long answer, and so that should explain to you what kind of answers we expect to see for this kind of question. Annika is drawing a pictogram where one picture is 5 children. Annika knows that more children have a birthday in winter than spring, but fewer children have a birthday in winter than autumn. Complete the pictogram showing one of the possibilities. So we've got all the seasons. I'm going to use my rucksack technique and I'm going to underline some important information. More children have a birthday in winter than spring. That was a terrible line. So in spring, I can see that there's nothing in there at the moment, but in winter, there's nothing either. So I can't really do that one yet. So I'm going to have a look at this one. Fewer children, that means less than, have a birthday in winter than autumn. So in autumn, we can see that there are 5, 10, 15, 20, 25, 30 children. So one possibility, I'm going to start by just trial and error. I'm going to put 10 children in winter and then see if I can do the spring. More children have a birthday in winter than spring. So this one needs to be greater. That's one possibility. There are more. See if you can find some different ones. Archie draws a pictogram to show Key Stage 2's favourite playground games. Each child voted once. Tig, which we call it, skipping, hopscotch and football. So we're going to find out if Archie is correct. I can already see he's incorrect because this is showing me how to answer the question. A quarter of the number of children that voted Tig voted football. So this is important. Remember, a quarter looks like this. A quarter. So when we are confronted by the word quarter, we need to divide by, go on, have a go. That's right, we need to divide by 4. So let's have a look. The number of children that like Tig: 10, 20, 30, 40, 50, 60, 70, 80. If you're wondering where I got the 10 from, it's from here. One picture, one circle is 10 children. 10, 20, 30. 10, 20. 10, 20, 30. A quarter of the number of children that voted Tig voted football. So if he's right, 80 divided by 4 should equal 30. But I know that 8 divided by 4 equals 2. But I'm not dealing with 8, I'm dealing with 80. So I need to make my 2 10 times bigger. No. So Archie is incorrect because 30 is not a quarter of 80. Okay, have a go, see what you can do today. Well done.